Yeah, good morning again. So now we keep the video record. Yeah, I hope you have good sleep last night. Yeah, and we have technical problem. So even some people in the class in on site attended on site, but we still need their own personal monitor to see the slide. But it's okay. All right. So well, hopefully that the internet we have good connection. If we have problem on the connection, we have to find the solution again. All right. And here I think, yeah, the air condition is the second problem. It's good. Air conditioner. Yeah. Okay, no problem. So you see my screen, right? Yeah.
Yeah, I can see your screen.
Okay. Any question from last time? Well, last time, of course, I introduced you the structure of the optimization problem. You see that we need objective function, right? Of course, our goal is to minimize or maximize. It depends. You minimize or maximize the objective function by adjusting the x. Our x is decision variable. Okay. And we have a set of constraints. All right. And that constraint can be equality or inequality. Okay. And then we discuss some things, the relationship between the optimization problem and degree of freedom. And now you know that, right? That optimization problem always has degree of freedom greater than 0. Okay. Because if you have degree of freedom of 0, you don't need optimization problem, right? Because it's actually an algebraic equation. Just solve the set of equation system, right? System of equation, then you got the solution. Okay, so and last time we talked about classification of optimization problem. Remember, right? We can classify based on various things. For example, existence of constraint. So it can be unconstrained problem or constrained problem, right? Of course, unconstrained problem is much easier than constrained problem. Okay, in for solving, I mean, yeah. And we can classify the optimization problem based on the nature of design variable. Okay, it can be parametric or deterministic, and I mean static optimization problem. And what else? Classify based on physical structure of the problem. Okay, well, if your function, your variable, or your function involve element of time, I mean, well, the x decision variable depends on time, right? It can, it can be adjusted during the time cost. So in that case, it's dynamic programming or optimal control problem. And what else? Yeah, classifying based on nature of equation involved. For example, linear programming, nonlinear programming, geometric programming, quadratic programming, whatever we learn of course. Yeah. For broadly, this classification, it can be linear and nonlinear. Okay. Anything involve nonlinear function, of course, we treat it nonlinear. But nonlinear, it's a big group because nonlinear function can be various type, right? So we can classify it based on quadratic or geometric, something like that. And what else? yeah, classification based on the permissible values of the design variables. For example, if your decision variable can be only integer, of course, we call it integer programming. You know, integer, right? 1, 2, 3, 4. Yeah, it cannot be 1.3, 1.3. And real value programming problem. Yeah, for the rest can be, well, anything. The decision variable can take any value. And what else? Yeah, classifying based on deterministic nature of the variables, classification based on the separability, the function, also number of objective functions. Okay, and we talk about, last time we talked about the procedure for modeling and solving optimization problem. Okay, the course involved 3 major steps, right? The first one, we formulate the optimization problem first. Yeah, and once you formulate it, what is it? Formulation of the optimization problem. It's a, what's it? Representation of real world problem. You translate it or represent it as a optimization problem. Okay, for real world problem, you know, it's not mathematics, right? So you capture some feature and translate it or represent it as a mathematical programming. Okay, so you can guess in this case, because we deal with optimization problem, we translate our real world problem into optimization problem, where we involve minimize of something, minimize of objective function, of course, and set of constraint, also these decision variables. Okay, and once you formulate it, the next step is solve it, to solve it, right? And you see that for real world problem, well, we have a number of ways to, what's it, to formulate the optimization problem. You can present and represent your function as linear function or nonlinear function. Even nonlinear function, you have, well, full of freedom to select some function to represent your model, right? So the way you formulate the optimization problem affect the way you solve it. You got my point? Because if you formulate it as linear function, of course, you target at using linear programming to solve that problem. Okay. And for nonlinear function, of course, you need, yeah, other solver to solve it. Okay. And you know, well, each type of problem and also different solver require different resource. I mean, resource mean, well, computational time and also, yeah, the solver you have. Okay. So before you start formulate your optimization problem, you have to think about the second step first. The second step is solving the problem. You have to think the solver available in, yeah, in your company, in your lab, of course, because if you formulate the optimization problem very sophisticated, but it cannot be solved by your solver, it's useless, right? Okay. And then the second thing is tractable solution, because, well, sometimes we need solution in a limited time. We have to solve it in a specific time. For example, you need solution in 1 minute. Yeah, yeah, in the case of control problem, optimal control problem, most of the time you need the solution in, well, less than 1 minute, because you have to implement the solution in 1 minute. once you solve the problem. That means, well, you have a limited time, right? You cannot solve this very accurately. Maybe you cannot use very sophisticated model. Because, well, it will be useless if you take one day to solve the problem, but you need that solution in 1 minute. Okay. And the last one is interpretation of the obtained solution. Interpretation means, well, because we start from real world problem and we represent it in well, using the mathematics, right, in a specific form, and you solve the solution. Once you got solution, your solution have to be implemented in real world problem again. So you have to check your solution if it, well, good enough for your problem. Okay, if not, of course, maybe you have to reformulate your problem again. And well, we talked about how to define the objective function. Okay, there are a number of ways to define the objective function. Of course, here I list some, yeah, the function that the parameter people usually use. And what else? This one is yeah, the objective function. Sometimes, well, for the simplest one, and also most of the time we use single objective function, right? We just use a specific function to represent our goal. Okay, but in real world, of course, sometimes you have multiple and conflicting objective function. For example, well, you want to buy something. For example, you want to buy a car, right? You go to showroom, and of course, what do you think? Well, normally, have you ever bought a car? No, just only run the car. Okay, well, you have to think about your budget, right? What else? Maybe you need the power, right? You have to think about the engine, how large, yeah, maximum power of the engine, and also other things, right? So you see that it's not a specific one single objective function. Okay, so actually these have multiple objective function. Of course, people will need a very cheapest one. It's the cheapest one, but highest performance. And you see that it's conflicting objective function, right? You cannot have both in one car. So in that case, of course, actually it's a multiple and conflicting objective function. Okay, and by solving such a problem, multi-objective function optimization problem, well, your solution is a set of Pareto. We call it Pareto set of non-dominated solution. Okay, and what else? Last time we talked about minimax objective. So in this case, you try to minimize the maximum of objective function, something like that. For example, in the case of robust control, we find the parameter, tuning parameter of controller in order to reduce the error. Because the smallest error is the highest performance of controller. But you know that, well, we need controller, the control system, because we have disturbance. So in a range of given disturbance or variability, we have to find the control parameter, tuning parameter that minimize the maximum error. Okay, and maximum error is just adjusted by the disturbance or variant Yeah, variability. Okay. What else? And we talk about how to define the constraint. Okay. For example, productive capacity constraint. Okay, the constraint defined by capacity of the process, of the equipment, whatever. Okay. And for that one, for the capacity, usually we formulate it as inequality constraint. Okay, because your reactor is 100, maybe 100 liter. You don't have to run your reactor at full capacity, right? 100% capacity. You can run your reactor at 50% of capacity. It's possible. Okay, and next thing is marketing demand. Oh no, raw material availability. For raw material availability, what do you think? We should formulate it as equality or inequality constraint. Inequality, right? Yeah, because well, raw material availability define the maximum, right? Maximum we can use, but we don't have to use that all. And what else? Marketing demand and limitation. This is quite complicated because most of the time marketing demand is defined by contract. In the case you have contract, of course, this constraint is equality constraint, not inequality constraint, right? You promise with anyone, you have to keep the promise. And the next one is material balance. Material balance, continuity constraint, not only material balance, also energy balance and other thing model. And for these constraints, yeah, they should be formulated as what? Equality constraint. Okay. You cannot violate the material balance, right? Whatever you fit to the system, it will, yeah, of course, it will flow out. And the next one is quality stipulation. For quality stipulation, actually, it is inequality constraint. Okay. And we talk about hard and soft constraint and chance constraint. Also, we discuss about how to build a good model. All right. Okay. So last time we did the first example already. For this example, we did it last time. Do you have any question on this one? A very simple one though. All right. If not, we move to the second one. Oh, yeah. I want to remind you something here for the first example because we skipped talking about that point, but we use it, we implement it in our first example. It is non-negativity. You see, non-negativity. Okay, this is important. Later, of course, I can show you that without non-negativity, you will get wrong solution. Non-negativity. Okay. For example, for production, you have to produce it as a positive number, right? You cannot produce it as negative number. Okay. Yeah. For example, if you model your objective function is cost. If you focus on the cost, you see that if you produce it as negative number, the cost will be opposite way, right? Okay, so the next one is multi-period example. Okay, this is a new content for this week. It's multi-period example. This class of optimization problem we call multi-period optimization problem. So for multi-period optimization problem, well, it's a problem involved, was it the plan for production, for whatever. But our problem involve multiple periods. For example, we plan for production for 6 months, but you know that you plan for each month separately, okay? But the whole cost is 6 months or one year, whatever, okay? So you see that we separate the whole time frame into a number of periods, okay? So we okay, we go to the example first. For this example, we have KW Oil, okay, a company. KW Oil has developed a dependable model to forecast future demand for oil. Okay, you see that this company already have model for forecasting the demand of oil, right? For each of the following 4 months, the company expects the following amounts of demand for heating oil. Okay, by using the model, they forecast that the first month the demand is 5,000 liters, and the second month demand becomes 8,000 liters. Yeah, and then 9,000 and 6,000 liters for the subsequent months. And at the beginning of the first month, the company may purchase heating oil from regional supplier at the current market rate. And the following table shows the projected price per liter at the beginning of each of these months. Do you understand the problem? Okay, they have price of each month, and each month the company has to must purchase oil at the beginning of each month at certain price listed in this table. Okay, so but the company has a small storage on its facility. The tank can hold up 4,000 liters of oil. Okay, and currently the storage contains 2,000 liters already. Okay, and the company wants to know how much oil it should be purchased at the beginning of each of the 4 months, such that it satisfies the projected customer demand at the minimum possible total cost. Okay, so the company has model to forecast the demand, right? And they know the price of the oil of each month. Okay, and what else? At the beginning, the container has oil 2,000 liters. Okay, and the maximum capacity of the storage is 4,000. Okay, and yeah, the company wants to know the plan. How much oil to be purchased at each month. Okay, so can you tell me the number of period? 4, right? 4 months. They plan to purchase oil at the beginning of each month. The first month, second month, third month, and fourth month, right? And the target is, what is the target? Minimize the cost, okay? Clearly. minimum possible total cost here. So now we think about this variable. They want to know the plan, right? The plan of how much oil to be purchased. So the amount of oil purchased at the beginning of each month, we use PI. And PI we have 4, right? For months, for period. So we have P1, P2, P3, and P4. Okay. But in short, we call PI, and I is, well, ranging from 1 to 4. Okay. So actually we have 4 variables involved in this, but we write as a vector P. Okay. And this is a special case of, what's it? Not special case, special feature of multi-period optimization problem, that it needs auxiliary decision variable. Okay. Here we represent it as TI. Okay. We call it, multi-period variable TI. It is the amount of oil in the tank at the beginning of each month. All right. At the beginning. Okay. So we have T1, T2, T3, T4. It represents what? For T1, of course, it's what's it? Amount of oil in the tank. And for T2, it is the amount of oil in the tank at the beginning of second month, right? Okay. So now we look at the objective function. For the objective function, because no income involved in this case, the target is only minimize the cost, total cost. So we look at the cost. Okay, we try to minimize the cost. And if we look at the cost, what is it? We have, what is this one? 0.75. Yeah, price of oil, right? So for the first month, okay, and we're going to buy it P1, right? The amount, yeah. So the total cost for purchase of the oil at the first month becomes 0.75 P1, right? Straightforward. And the second term is the cost of purchase of oil at the second month. Okay. And third month and fourth month. Okay, very simple, right? So now we look at the constraint. The constraint, we look at the what is it? The constraint on the storage tank first. We have T1 at the beginning of the first month. I mean, the amount of oil in the tank. And we purchase P1, right? So P1 plus T1 must be equal what? Equal 5,000 plus T2. What is it? 5,000 here. 5,000 here is the demand. Yeah, right. Because 5,000 liters of oil will be sold to our customer, right? And the rest becomes T2. Okay, you see that P1 plus T1 must be 5,000 plus T2. And for the second month, P2, the amount of oil purchased in the beginning of the second month, plus the amount of oil in the tank. All right, at the beginning of the second month. Okay, and we're going to, what's it? Sell it to our customer, 8,000 liters, right? Because the demand is 8,000. Okay, and the remaining becomes in the tank. Okay, plus T3. Okay, so balance at the third month also, P3 plus T3 is 9,000 plus T4. Okay. And the last one, P4 plus P4 must be greater than 6,000. Okay. Okay, so for the tank capacity, we know that the maximum capacity is 4,000. So for each TI must be lesser or equal 4,000. Okay, whatever greater than this one will be exceed the capacity of the tank, right? We cannot keep it. And for the first month storage, T1 is 2,000, right? Because, well, the company already have 2,000 at the beginning of the first month. Okay, and the rest is non-negativity. You cannot purchase negative value of oil. Also, the amount of oil in the tank must be positive, cannot be negative, okay? TI must be greater than 0, and PI must be greater than 0. Okay, so for this question, this problem, we formulate the optimization problem as minimize, yeah, our objective function, and our decision variables are TI and PI. Okay, and we have set of constraints, a set of constraints. Okay. Okay, any question? Also, any question from, yeah, from remote? Pardon? Say again. Minimize objective function, right? Reducing of what? Okay, you mean, well, if the company wants to do something else, for example, maximize the profit or do other thing. Yeah, right. Yeah, right. At each period, no. Because of what? Because you cannot do that in order to satisfy the minimum of total cost. Because of what? Because in some months, the price is smaller, right? And of course, your strategy must be, you have to buy the maximum as much as possible in that month. And you see it's conflict, right? Because that the cost for that month will be, yeah, maybe maximum. Okay. But for the total cost, of course, the cost is minimum. Okay. But of course, it depends. It depends on the condition. In some case, of course, if you have information, if the company has other constraint, maybe, well, at the certain month, they cannot, they have only limited amount of budget. In that case, of course, you have to formulate that constraint. Okay. Yeah. พูดดังๆ ไม่ค่อยได้ยินเพราะว่าใส่หน้ากากอ่ะที่สองคือน้ำมันที่จะต้องที่มันอะไรนะเหลือเดือนไหนก็แล้วแต่เหลืออยู่ในถัง เพราะมันเป็น strategy ที่ยังไง เราซื้อมาแล้ว เราไม่จำเป็นต้องใช้หมดเดือนนั้น เราซื้อเราก็เก็บไว้ใช้ในอนาคตได้ ครับ Okay, she asks about the T2. Why we need T2 here? Yeah, because of course it's a feature of multi-period. Because you can what's it? You can buy more than what you can sell in that month, right? As if the price is attractive at that month, you can buy it at lowest price and then keep it, yeah, to sell it in the future. Okay. Any question from online? You Reza, right? Reza, okay. You are Iranian. Saku, you, right? Okay. Yeah, Saku should be family name or first name. Oh, okay. Yeah, but for me, if I see your name, I think that Amara should be first name because Amara Thai name is first name. Saku and Vishuddha, right? Supervisor is not here. Samson is not here. Kadim. And you, Asan. Ahmad, okay. Okay. So Asan is online. All right. Any question from online? You can leave it in the chat box.
Yes,
Okay.
sir. Yes, sir.
Okay, so we move to the next question, next problem. This one is assignment problem. You see that's very simple, right? Our problem, our optimization problem is very simple. Yeah, always example is the very easy, very simple. Okay, so the next one is assignment problem. For assignment problem, our idea is, what's it? You have a number of jobs and you want to assign the job to different people. Okay, in order to, what's it? Maximize the performance. Maximize performance means, well, minimize the time required to complete the job. Right? For example, I plan for cleaning this room. Well, and it involves, well, maybe you clean the table, you clean chair, and well, you clean other parts, right? And we have, well, 6 people here, so we have to assign the job for each one. All right, and you know that each people had different set of skills. Okay, so if I ask you to clean the chair, maybe you do it very fast, but I ask you to clean the whiteboard, then you, well, maybe slower than others, for example. That is the idea, right? So for this one assignment problem, there's a set of J jobs that need to be handled. Okay, the company has selected I employee to handle these jobs. Naturally, the skill set of these employees differ, and not all of the jobs are equally well handled by all of the employees. Management knows the number of hours. Okay, CIJ, we call it CIJ. Each worker, I. Okay, I represent worker, each worker. Okay, each worker is expected to take in order to complete any of the job, J. Okay, J is the number of jobs. So the following table gives an example for a case that the number of jobs is 4 and the number of employee is 4. Okay, in this case, number of jobs is equal with number of employee. Okay, we have 4 employee, we have 4 jobs to be handled. All right, the task is just assign each one to each job. Okay, and this table represent the the skill set of each employee. Okay, for example, employee 1, if employee 1, well, take the first job, they need 3 hours. Okay, if they take the second job, it needs 5 hours, something like that. Okay, got it? All right, so the company wants to assign jobs to employees with the condition that each employee is assigned exactly 1 job for this case. And the second one, each job is assigned to exactly 1 employee. Okay, 1 job can be handled by only 1 employee. Okay, and 1 employee can only take 1 job only. Very simple, because you have 4 jobs and 4 employees. Okay, if any employee take more than 1 job, you see that, well, 1 will be free. That, yeah. So in this case, well, we will not allow anyone free. Okay, so both of these conditions can only be satisfied when the number of I equal number of J. All right, and we want to find such an assignment that minimizes the total expected amount of time needed to process all jobs J. Okay, okay, now you know the objective of the company. What is the objective of the company? Yeah, minimize the total time, right? Yeah. And what about decision variable? Decision variables. Pardon? Yeah, and how to write down as a mathematic, as a variable. Pardon? I cannot hear you clearly, sorry. Xij and well, what number X takes? Yeah. And what about X? Xij can take any number or from true and false. Yeah. Sorry, because, well, we wear masks and I cannot hear you clearly. So, yeah, Xij is okay. And X should take only 0 or 1. Because true or false? No, 0 or 1. If not 0, it should be 1. 1 represent true, 0 represent false. You got the point? No? Yeah, but you know that when we make a decision variable, the decision variable should represent all the scenario, right? Because you don't know that which one which employee take any job, you don't know yet at the beginning, right? So you need a variable that can represent any possible scenario. Okay, so the decision variable is xij. Okay, it represents the condition that the employee I is assigned to job J. If it is 1, it means that I employee is assigned to job J. If this value is 0, it means no. Okay, you got my point? Okay, so with this metric, you see that it actually is a metric, right? Metric of X is a metric of I and J, right? And this metric contains a binary values, okay? The binary matrix, because each element can be only 0 or 1, 0 or 1, okay? And it represents true or false, okay? But sorry that we cannot use true or false in numeric. It should be 0 and 1. Okay, and what about objective function? The objective function is Cij comes with Xij. And it should come with, what is it, element by element, not a matrix. You got the point, no? Cij, what is Cij? This is Cij. No, Cij is this one, right? And we have Xij, which is similar to this one, but it contains only 0 or 1, right? And you see that if each element is 0, it means that that employee does not take that job. But if it is 1, it takes that job. So if we multiply each element of Cij to Xij, we obtain the number of hours that employee take that job. Okay, because if that employee doesn't take the job, it multiplied with 0, so it becomes 0. Okay, you got the point? No, not yet. Okay, I will write it down in, yeah. You see my iPad, right? What we have? I have to write down that Cij again. 1, 2, 3, 4. Employee, this is J, right? This should be I. No. Yeah, in opposite way. This is employee, and this is J. Okay. We have 3, 5, 1, 7. Okay. And we have another table of xij. And you see that it can represent 0 or 1. For example, this scenario. Okay, this is only one scenario, one option, I mean, one solution. And this solution, you know, the employee 1 take job 2, right? Employer 2 take job 1, right? Yeah. And employee 3 take job 3. Employee 4 take job 4. Okay, this is one scenario, right? And if I multiply Cij with Xij, we multiply with element wise. Okay, element by element. What is it? It becomes 0, 5, 0, 0, right? 8, 0, 0, 0, right? 0, 0, 6, 0, and then 0, 0, 0, and 2. Okay. And pardon? Don't understand what? Okay. Thank you. Yeah. So you see that if we multiply it and then we sum all elements together, we obtain the total hour required. Yeah, for the whole group. Okay. So so our objective function is just to mix. What is it? Oh, sorry, I have to switch back to this one again. All right. So you see, we sum up by I, okay, and we sum by J. That means we sum all the elements, okay, of Cij, Xi. Okay. So each employee, sorry, is assigned exactly one job. Okay. What does it mean? For I, for this one, if we look at X, by this I, for each I, the summation must be only 1. Okay, that means in the same row, or in the same column, sorry. Yeah, in the same column, the summation must be 1. Yeah, because we allow only 1 people, to take one job, and also in the same row, right? Must be 1. And one job must be handled by only 1 people. Okay. Okay, each employee is assigned exactly 1 job. So summation of Xij must be 1 for each I. And each job is assigned to exactly 1 employee. So for each J, summation of Xij by all J, by all I must be only 1. Okay. 1 row, summation by rows must be 1. Summation by by row and by column must be 1. Okay, so our optimization problem becomes minimize xij, okay, of sigma I and sigma j, right? Cx, okay, Cij, Xij. And constraint is, yeah, in the same row for each row, and each column must be, summation must be only one. Okay. And Xij can take only 0 or 1. Okay, it must be binary. Yeah, any question from home? Huh? Any question? Yeah. Can you come, yeah, in front? No, yeah, you just bring your notebook and say, because I cannot hear from that way, you know. Huh? No. You come, yeah. You just walk here and say, I cannot hear, sorry. I lost my, yeah, my sharp eye last year, and this year I think my ears too. Okay. From the table. From this table. Yeah, just one moment. The maximum is yeah, because you have to satisfy other things. Yeah. In this case, it's very simple because you have only 4 jobs and 4 people. Think about, you have 100 of people and you have more complicated condition to be satisfied. Yeah, this one, as I told you, yeah, example is very easy. To show you the idea, right? Once you understand, of course, you do it in exam, you will be, yeah, feel more challenged on that.
It might be affected and because very like example, we do make some assumptions as well. So that time I think something from getting to the formula assumptions as well. So how to differentiate between constraint and assumption and
Constraint and what? Assumption. Yeah, the first question first, and then we will later we will deal with the second question. For assumption, of course, your assumption affect your model, right? So I cannot tell you, well, when to, what should be assumed constant, what should be assumed that way, this way. I cannot say. Yeah, I can tell you only the problem in a well-defined problem, like, yeah, question like this. Okay, but in real situation, you have to think of that by yourself, because once you neglect some, assumption, you got different model and you got different solution, of course, right? That is the reason why you have to interpret your solution with the real world problem again. If it Yeah, is okay for you? No, not. If not, you have to, well, relax some assumption or maybe add more assumption on that. Mm-hmm. Yeah. Yeah. And what about the second question? Okay. Okay. Yes and no. Yes and no, because as I told you, if the problem is well defined, okay, you got only one optimization problem. Most of the time, you got only one solution for global optimization. Okay, even your solver obtain several solutions, but most of the time, there is only one best solution. Later, of course, I will tell you about the feature of global optimization problem that you have a number of, we call it local optimum point. Yeah, but in real world problem, what you said is right. That means we can have number of solutions, and those solutions, of course, can be applied in the real world problem. Yeah, but maybe different solution. Everything has their own cost. Okay, maybe they require different costs. Okay, and most of the time, I mean, for real world problem, I ask you to formulate the problem. I ask you to formulate the problem. Surely you got different solution model for me. And once you got different model, of course, you got different solution, right? Okay. And this is not the only way. I mean, this assignment problem, this is not the, what's it, only single way to formulate the decision variable. You can design your decision variable different way. Okay, but this is the most efficient one we have. By assign that X matrix, and then yeah, very easy to understand, right? That one. Okay, the next problem is, we call it knapsack problem. When knapsack problem, you well, for example, you have, what is it? I can, yeah, we look at the problem. A company wish to ship a number of crates from Toronto to Kitchener. Yeah, you don't have to know it's Toronto and Kitchener, but somewhere in the earth. Okay, in a freight container. Okay, ship in a freight container, and the crates are 6 possible types. Each type of crate has a given weight in kilograms and has a particular retail value in dollar, as indicated in the following table. Okay, we can accept 6 types, right? 6 possible types: type 1, type 2, type 3, type 4, 5, and 6. And the weight is 30, 20, 30, 90, 30, and 70. And the value can be, well, 60. The values are 60, 70, 40, 70, 20, and 90 again. Okay, so we have condition. The first condition is you cannot send more than 10 crates of the same type in the container. Okay, you cannot send only one type 1 more than 10 crates. You can only send crates of type 3 if you send at least 1 crate of type 4. You got the point? You understand the condition, right? If you want to send type 3, you have to send at least 1 of type 4. And at least one of the following two conditions has to be satisfied. A total of at least 4 crates of type 1 or type 2 is selected, or a total of at least 4 crates of type 4, type 5, or type 6 is selected. Okay, think about it. Okay, so the total weight allowed on the crate container is 1,000 kilogram. Okay, 1 ton. Your goal is to design how many crates of each type to place in the crate container so that the value of the crates in the container is maximized. Okay. You have constraint on weight, the weight. And you want to maximize the value. Okay. And beside that, you have, well, 3 constraints. Okay, so what we want to do? What is decision variable? What are our decision variables? The number of crates for each type, right? So we use xi, okay? Xi, well, actually x consists of x1, x2, x3, x4 to x6, right? Yeah, we have type 6. And x takes real, actually it should not real, it should be integer. Okay, you cannot send only half of the crates. Okay, but x is the number of crates. It can be only integer. And we have logical variable here, we call it y, to handle the constraint satisfaction. I will tell you why we need it. Okay, but at the beginning, you have a question why we need this y. Okay, but later, yeah, I will tell you. Let us look at the objective function first. Our objective function is to maximize the value. So we know that our decision variable x1 is a number of crates for type 1. x2 is number of crates for type 2. Okay, so for the whole objective function, it can be 60x1, right? Because 60 is a value of type 1, right? Plus 70x2, 40x3, 70x4, 20x5, and 90x6. Okay, you got the objective function, right? Understand it? Now the constraint. The constraint, the first simplest one is the total weight. Because the total weight is 1,000 kilograms. So it's very easy. Just take multiply the weight of each crate by the number of each crate. Okay, and then sum up all type. So 20x1 plus 20x2 plus 30x3 plus 90x4, 30x5, and 70x6. Totally, this number must be lesser than 1,000, lesser or equal 1,000. Okay? Should be no problem, right? And yeah, for the first constraint, back to the constraint, you cannot send more than 10 crates of the same type in the container. That means for xi must be lesser or equal 10. And the next one is x. What is it? You can only send crates type 3. if you send at least one crate of type 4. Okay, so I write this constraint as x3 must be lesser than 10x4. X3 can be more than 0 if x4 is at least 1. Okay, got it? No? You know, well, you look at this one. X3 must be lesser than 10x4. If x4 is 0, you don't send any crates of type 4, x4 must be 0, right? And then x3 is automatically be 0, right? Because the right hand side is 0 already. If x4 is already defined to be 0. Okay? X3 can be any value if x4 is at least 1. Okay? You may have question, what about x4 is 2? No problem. If x4 is 2, from this constraint, x3 is lesser or equal than 20, right? It's okay because the constraint, the above constraint already defined that x3 must be lesser than 10. Okay. พิมพ์เข้าใจป่ะฮะมัน x4 มันต้องอะไรนะต้องมีค่าก่อน x3 ถึงจะมีค่าได้เพราะเขาบอกว่าจะส่ง x3 ได้ต้องส่ง x4 เพราะฉะนั้น x4 จะไม่เป็น0ได้ก็ x3 จะไม่เป็น0ได้ x4 ต้องมีค่าขึ้นมาก่อนโอเคมาจาก constraint นี้ไงมาจาก constraint นี้ you can only send crates of type 3 if you send at least one crate of type 4. No. type 4 ต้องมีค่าก่อนถึงจะมีถึงจะส่ง type 3 ได้ต้องส่ง type 4 ก่อนไม่เกี่ยวข้อจำกัดแรกข้อจำกัดแรกบอกว่าแต่ละชนิดส่งได้ไม่เกิน 10ไม่เกิน 10ไงไม่เกิน 10ข้อจำกัดแรกบอกแค่ว่าไม่เกิน 10มันจะเป็น0ก็ได้ constraint แรกอ่ะจะเป็น0หมดเลยก็ได้แต่อันที่2บอกว่าถ้าจะส่งอัน3อ่ะต้องส่งอัน4ด้วยต้องส่ง type 4 ด้วยเพราะงั้นเราเลยต้องมาเขียนอันเนี้ย x3 ต้องน้อยกว่าเท่ากับ 10x4 ครับ yeah if x4 20 10 right yeah but less than 20 and less than 10 you are limited by 10 right equal constraint can be active or not active, right? If x4 is 2, x3 is lesser than 20, this constraint become inactive. because it's already defined by 10. Mhm. Well, you want to remove that 10, right? X3 lesser than X4, right? Well, we have problem because of what? Because if what is it? X3 lesser than X4. Okay. The condition is you need only one crate of X4. You can send any number of crate 3. If you write the constraint as X3 lesser than X4, that means, well, if X4 is 1, you cannot send 3 or 2 or, well, more than 1 of X3. But the real condition, it allows to do that, right? You can send 5 of crate 3 if you only send 1 of crate 4. You got my point? You got my point? Back to the constraint first. You can only send crates of type 3. That means X3 can be any value, well, can be greater than 0 if X4 is greater than 0. If X4 is positive, well, X3 can be anything positive, anything greater than 0. Okay? Less than 10, of course, we talk about this one. You don't care about that 10. It's already defined that. That means if you X4 is 1 and X3 is 2, I ask you, is it satisfying this constraint? Yes, why not? The condition just say that, well, you send X3 if you send X4, at least 1 of X4, right? No matter you send how many X3 you send, I mean less than 10, of course, you need 1 of X4. That means X3 can be greater than X4, right? Okay, so if you look at this constraint again, we write X3 lesser than X4. If we write that way, without 10, X3 cannot be greater than X4. Right? So we times by 10 here to allow it, well, can take any number as long as X4 is greater than 1. X4 is not 0. X3 can take any number. Okay? You may have a question. Why 10? Can we have 100? Can we have 200? Yes. No problem. You can take any number greater than 10. Because of what? Because X3, the maximum X3 is already defined by the above condition. Even, you see, even we put 100 here, we got X3 lesser than 100 X4. If X4 is 1, X3 must be less than 100. It's okay. Because it's already defined by the above constraint that X3 must be less than 10. You got it? Okay. Okay, the next constraint is more complicated. At least one of these conditions. That means the first condition can be true when the second condition can be, yeah, false, or in opposite way, or both can be true. But the first thing, you have to understand the condition first. A total of at least 4 crates of type 1 or type 2 is selected. Or a total of at least 4 of type 6 or type 6 is selected. Now look at the constraint. The condition, remember the condition? Must be greater than 4, right? Okay. Okay. We have why here because at least this condition must be true. We have 2 conditions, right? The first condition is at least 4 of type 2 or type 1 or type 2 is selected, or at least 4 classes of type 5 or type 6 is selected. Okay. So we don't need both to be true. Anything, yeah, can be true. So I put y here. Y represents the yeah, y can take is binary variable. It can take only 0 or 1. Y1 means the first condition is true. Okay, you see that we put y, yeah, you can put y1. So x1 plus x2 must be greater than 4. That means the first condition is true, is correct. Okay. And you see the second condition. You don't have to pay attention to that one anymore because the second condition becomes x5 plus x6 greater than 4 times 1 subtract by 1. 1 minus 1 is 0. Yeah, then becomes 0. So it doesn't matter. x4 plus x5 must be greater than 0. It's okay. Yeah. x5 can be 0. x6 can be 0. Okay. Okay. And what about y is 0? If y is 0, the first condition, x1 plus x2 greater than 0. It's nothing, right? But we force the, what is it? The true of the second condition. The second condition must be satisfied. x5 plus x6 must be greater than 4. Okay, got it? So y is an auxiliary variable, represent the, what's it? Which condition is true, I mean. This is the way we formulate the objective function with, yeah, by complicated conditions.
But it is like we can like one of the situations, right? But if we want to satisfy both situations,
Yeah,
if that is our
yeah, you beautiful. If you look into the detail, you see that even y is 1, the second condition is always true. That means you can satisfy that one too. Right? For example, y is 1, x1 plus x2 is greater than 4, right? Satisfy the first one. And the second condition becomes x5 plus x6 greater than 0. That means it can be 4. Right? Yeah, in an opposite way also, you force the second condition, x5 plus x6 to be greater than 4. But the first condition is greater than 0. It can be 4, right? Okay. So the last and most important one, x1 must be, no, not x1, xi must be greater than 0, greater or equal 0. It cannot be negative. Yeah, it's non-negativity constraint. For the knapsack problem, yeah, this is the solution. We maximize our objective function. Oh, I forgot y here. the decision variable should be y also, not only xi. Okay, here we should have y and xi. And the constraint 30x1 plus 20x2, 30x3, 90. Yeah. And non-negativity. And xi must be integer. And y is logical, 0 or 1. Okay, any question from remote? Samson, you have any question? I cannot hear you. If you have question, you can write in the chat box. Asan, you have question?
No, sir.
Pardon?
No, sir.
No, okay, all right, good. Of course, if you have any question, anytime you put in a chat box, okay? And yeah, the next one is production and procurement planning. I think we can stop for 5 minutes. Yeah, let us break for 5 minutes. Okay, we back to our class. The next one is production and procurement planning. For this one, well, it's actually, you can treat it as a multi-period optimization problem because, well, but it's more complex, more complicated than the multi-period optimization problem. Okay. We have a company, a food company manufactured by refining raw oils, and blending them together. The raw oils are of two categories: WEC1, WEC2, vegetable oil. I mean, vegetable oil 1, vegetable oil 2, and oil 1, oil 2, and oil 3. And each oil may be purchased for immediate delivery. You, for example, in January, you purchase it at the beginning of the month and process it and blend it and sell it that month. Okay? Or you can buy it on the future market for delivery in subsequent months. So price at present and in the future market are given in this table by dollar per ton. Okay. Well, we should have 6 months. Yeah, it's 6. 1, 2, 3, 4, 5, 6. 6 months, and we have WEC1, WEC2, oil 1, oil 2, oil 3. Okay. And the price is dollar per ton at each month, in the beginning of each month. Okay, the final product sell at $150 per ton. Okay, no matter you buy different raw oils, WEC1, WEC2, oil 1, oil 2, oil 3, you process it, you mix it to meet the condition, you sell it at the same price. You sell it at 150 per ton. That means you have only one product. Okay, only one product. So vegetable oil and non-vegetable oils require different production lines for refining. Okay, because you have to buy raw oils, right? You have WEC1, WEC2, oil 1, oil 2, oil 3. Once you buy it, you have to process it. You cannot just mix it first and process. You have to refine it separately, okay, before you mix it finally. Okay, in any month, it is not possible to refine more than 200 tons of vegetable oils and more than 250 tons of non-vegetable oil. Okay, this condition defines the maximum capacity for the refinery of vegetable and non-vegetable oils. Okay, and there is no loss of weight in the refining process. Okay, we assume it. This is assumption. And the cost of refining may be ignored. Okay, no matter how many you process it, the cost for refining is almost similar, so you ignore it. And it is possible to store up to 1,000 tons of each raw oil for use later. Okay, you buy it at this month and you keep it in your storage tank for future. And the cost of storage for vegetable and non-vegetable oil is $5 per ton per month. Okay, this is the storage cost. For example, you buy it this month and you want to keep it for 1 month, you have to pay $5 per ton per month. And the final product cannot be stored nor can refine oils can be stored. Okay. You can store only the raw WEC 1, WEC 2, or oil 1, oil 2, oil 3. That's that. Okay. We have constraint on the, some restriction. There is a technological restriction of hardness on the final product. In the units in which hardness is measured, this must lie between 3 and 6. Okay. And it is assumed that the hardness blend linearly, and that the hardness of the raw oils are WEC 1 is 8.8, WEC 2 is 6.1, oil 1 is 2, oil 2 is 4.2, oil 3 is 5. Okay. Linearly proportional. So what buying and manufacturing policy should the company pursue in order to maximize profit? This is a question. And more information. At present, there are 500 tons of each type of raw oil in storage. It is required that these stocks will also exit at the end of June. Okay. At the beginning, you have 500 tons of each type of raw oils. And after 6 months, you have to, remain. Yeah, in the tank, you have to keep the same amount. Okay, so what to do? No solution here. That is a book or notebook? It's notebook. Okay, yeah, very big and thick. Okay, I will share my iPad instead. We need decision variable. Okay. For decision variables, can anyone suggest? The amount of oil. Okay. Purchase, right? Okay. We use P. P is the amount of oil we purchase at the beginning of each month. Yes, and we have 4. No, we have 5 types. 5 types. WEC 1, WEC 2, oil 1, oil 2, oil 3. And J. So I can be WEC 1. I is, what's it? 1 to 5, right? WEC 1, WEC 2, oil 1, oil 2, oil 3. And J can be month. Yeah, 1 to 6. Okay. This is metric represent the oil, each oil, the amount of each type of oil we purchase at the beginning of each month. And what else? Storage. Okay, storage. So tank. TIJ. T is in the tank. Okay. We have tank for each oil, each type of oil. And we have 6 months. Okay. There's a beginning. The amount of oil in the tank at the beginning of each month. And what else? We have SIJ. SIJ is, yeah, process and sell. We have to refine it, blend it, and sell it. Right? So this is the amount of oil, each type of oil that we refine. Okay, and blend it and sell it. All right. Okay, so yeah, similar way. Objective function. For objective function. Objective function. For objective function, what is the objective function? What is the objective of the company? Maximize profit. Okay, so we have to write down the profit. Profits consists of 2 or 3 terms, but actually 2 types: income and cost. Okay. For income, just one moment. The price of the final product is 150, right? And the amount is summation of SIJ. Okay. Because SIJ, of course, you have I represent each type of oil, but no matter any type, you have to buy it, and the amount, no loss on the during the process. So the final amount is the same as the equals the amount of raw material. Okay. So summation of SIJ. Okay, got it? Any question on that? Okay, so what about the cost? The cost we have purchase, right? For purchase, one, we have to subtract it by what? Summation of I and J on CIJ and PIJ. C is the cost. Yeah, cost factor. Okay, and P is the amount of oil, right? So we have to multiply it element wise, not a multiplication of the matrix, but element by element. Okay, we have to multiply C11 with P11, right? Multiply, yeah, similar to what we did previously in the case of assignment job. Okay. And for processing costs, we don't have processing costs, right? No loss of bed in the refining process, and the cost of refining may be ignored. So we ignore it. But we still have costs on storage. The cost of storage is $5 Yeah. With summation of T. Tij. Right? We can take the number only month by month. Anything in the tank at that month. Whoop. Anything in the tank at that month. We times it by 5 because we assume that it will, yeah, will cost, right? Okay. Anything else? No, no more, I think. You have costs on purchasement. You have costs on storage. Okay. Anything else? Any question? Oh, I got one question from the chat. เทอมสุดท้ายเขียนแค่ J ได้ไหมครับเทอมสุดท้ายเขียนเทอมสุดท้ายหมายถึงอะไรครับสุภวัฒน์เปิดไมค์ไปคุยก่อน
ก็มันสโตเรจทุกตัวใช่ไหมครับก็คือแบบว่าเราก็คิดแบบว่าเดือนต่อเดือนไปเลยอ่ะก็คือเราไม่ต้องสับสกิปไอ
ได้แต่ถ้าไม่มันก็เหมือนกันอ่ะเพราะว่าถ้าไม่อะไรนะไม่เขียนรวมเป็น IJ อย่างเงี้ยเราก็ต้องเขียนแยกเดือนbyเดือนเพราะฉะนั้นเทอมนี้ก็จะต้องมี6 เดือนโผล่มา
อ๋อครับ
อือฮึนะเพราะฉะนั้นก็เหมือนกันครับเขียนไหมครับโอเค How about what? Yeah, you come to, yeah, you have nice on, I can say 500 tons at the beginning, yeah. Yeah, we interpret it in the constraint. Not here. This is objective function. Okay. But the problem is the amount of oil in the tank at the beginning. Yeah. The problem is because maybe the problem is on how we define the cost at the beginning or at the end. You got my point? Because actually we should use the term of the amount of oil in the tank at the beginning of the second month to define the cost, the starting cost of the first month. Because of what? Because T1 is a storage at the beginning of the month. It should not affect the cost of storing, right? Because it's already there at the beginning of the month. Okay. For example, for T1 is the amount of oil in the tank at the beginning of the month. So you don't pay any storage for the whole amount of at the beginning of the month. It should be T2 because T2 is the amount of oil stored at the beginning of the second month. That means that amount of oil already stored for 1 month. Yeah, this point can be debated. Because storing, we don't know that we should count the amount of oil at the beginning or at the end. Okay. But I can tell you that it's almost the same because finally, we have to satisfy 500 tons anyway. So it should be the same. Mhm. Okay. All right, so we move to our condition. The availability, do we have availability limitation? No, we don't have. We have capacity. Limitation on capacity, refining capacity. So for capacity, we cannot refine more than 200 tons of vegetable oil. Okay, so the first element, PI, is yeah. So P1, no, not P1. P1, let's say I. So J, sorry. Plus P2, J. Vec 1, Vec 2, right? Cannot refine more than 200. Okay. For J is 1 to 6. The same. Okay. Huh? 1 and 2?
Yeah.
Vec 1, Vec 1, Vec 2. J is months. Vec 1, Vec 2. Vegetable oil 1, vegetable oil 2. We have vegetable 1 oil, vegetable oil 1, vegetable oil 2. Oh, sorry. It's not P. Sorry. It should be S. It's not the number, the amount of oil we purchase. Pardon? Yeah, the capacity. The capacity defined by the amount of oil we sell, not the amount of oil we purchase. Because we purchase and we can keep it to be used later, right? But for selling in that month, we have to process it before. Yeah. So it should be S1J plus S2J must be less than 200 because 200 is the maximum capacity of refinery. This one. Yeah, this one, this condition. It is not possible to refine more than 200 tons of vegetable oils. 250? Oil 1, oil 2, oil 3 for non-vegetable oil. Yeah, 3, 4, 5. 3, 4, 5 is oil 1, oil 2, oil 3. J plus S4J plus S5J less than 250. Okay, and J must be 1 to 6. The same. Yeah, in the example, of course, I write in short. But when you do exam, please write clearly. Okay. What else? What else? It is possible to store up to 1,000 tons of each raw oils. Okay. That is capacity of the storage tank. So Tij less than or equal 1,000. Okay. Also define the Ij clearly. Okay, any question? No? What else? The next one is mass balance at each month. Whatever in the tank, T1 is okay. Ti is okay. Ti1, okay, plus what we purchase, Pi1 must be Si1 plus in the tanks of next month. What is it? No? Okay. Okay, so we also have this similar thing to the second month. Okay. And the third month. And the fourth month. And the fifth month. Okay. But for the sixth month, we don't have Ti7, so it must be 500. Right? It must be 500 because well, it is required that at the end of the course, we have to keep the oil, each type of oil 500. Yeah, the same amount at the beginning. Okay, and at the beginning, Pi1 is 500, right? Yeah, and the next one is very important. Non-negativity. No, not the last one. I keep the most complicated one to the last, but this one is very simple. Pij Sij and Tij must be greater than 0. greater or equal 0. Yeah, and the most complicated one is the hardness. The hardness of oil must be between 3 and 6. All right. So for each month, you refine the oil and blend it. Okay. So, wow. For example, for the first P1, oh, no, not P, S, sorry, plus 6.1 S1 S2I, sorry. Plus oil 0.1 S3I, oil 1, plus 4.2 plus 5 okay, divided by all right. And this value must be between 3 and 6. Okay. Is it okay? Got any question?พูดดังๆน้ำมันชนิดที่ 1 ของเดือนไอเจไอจะเขียนไอหรือเจก็ได้มันไม่นั่นแต่ว่าโอเค yeah I should write J yeah if I write it I you well you may confuse โอเค J ก็ได้ครับจะได้ไม่งงbut actually it's the same right as long as you define correctly okay so that J represent the month okay and you see that if you write the constraint this way the constraint is not linear anymore this function is not linear because you divide the variable with variable okay it becomes nonlinear but actually this one can be formulated as linear function okay you know that well the summation of the total amount is not 0 for sure so we can multiply the summation you see denominator S1J plus S2J plus plus 2 S5J this one you multiply everything and you got linear function okay so 3 multiplied by that term big term must be lesser than 8 8.8 multiplied with S1J and so on okay and the other side also the same 6เข้าใจไหมไม่งงใช่ไหม เอาตัวหารมันคูณตลอด มันก็จะกลายเป็น linear function โอเค any questions no okay any question from remote Asan Samson สุภวัฒน์วัชรพิสุทธิ์มีคำถามไหมครับ Okay, good. No question, no question. All right. Of course. Okay, so enough for today, I think. Yeah, you got the whole slide, right? Yeah. Pardon? Yeah, right. No loss of weight. No, because no loss of weight. We don't have to put anything there. You see that what is it? This one. Because no loss of weight. So we can write TI1 plus PI1 is what it's equal SI1 plus TI2. If there is a loss of weight, S cannot be here, right? You have to multiply by something. For example, if we assume that 10% loss of weight, you have to, take that loss into account, right? This one. Yeah. We have that assumption in order to make the problem easier. Okay. Any question? You have the whole slide. So, well, next time we will talk about refinery optimization. Another thing, yeah. Very long. Yeah, very long. Factory planning and another thing. Okay, so enough for today. So enjoy the rest of the day. Okay. Bye. Have a good day. Maybe we will have rain today, maybe.
When did we start working on that?
Okay. So actually, once you, what I said, now we work on the formulation, right? But actually, well, if you know how to solve that problem, you can use the MATLAB to solve it. I think we will do in class, or maybe I can record some video to show you how to use MATLAB to solve the problem, and then, well, of course, you can solve the problem we formulated in MATLAB. Yeah, we also need Excel. All right, for MATLAB, of course, it's expensive, but you don't have to pay because university already paid for that one, so you know it, right? Okay, good. So while you use Windows or Mac OS, yeah, laptop. This also laptop, but is it Mac? Windows. Okay, Windows. Okay, yeah. Mac is also okay, right? But I asked that one because what? Because I don't have Windows notebook. So what I show you is based on Mac. You have to read me by yourself how to install it on Windows. Okay. แต่ใช้ iPad ไม่ได้นะ iPad ใช้ไม่ได้ MATLAB ไม่มีเวอร์ชันบน iPad ไม่ต้องครับ ก็อือฮึ and for the class yeah sometimes we do it on site we meet on site then sometimes of course we can do it online actually right yeah we will decide which when yeah next week maybe online yeah and also I will provide some what is it material online so you can learn by your pace okay okay bye bye goodbye everyone I will yeah we'll stop the Zoom